Yep, thank you. Hi, everyone. My name is Daniel. I'm software engineer in Reface, and today I want to talk about Structurizr Architectural Diagrams. And let's start with discussing what the definition, basically, of architecture diagrams, what they are. So architectural diagrams, software architecture diagrams, as any diagrams, tools for visualizing your software architecture. Basically, you want to make information about your services, about the ways that they interact with other services or other systems, third-party integrations, easier to comprehend. So that's why we are building them, that's why we are using them, that's why we are visualizing that information. There are many kinds and forms of software architecture diagrams. They can be drawn by hand, they can be assembled from stones, they can be drawn in a fancy software. Really anything that works for you to allow you to visualize that information goes. Yeah, so here we have a hand example, here we have a fancy diagram example. This one is a bit more complicated, and also the next one. Yeah, so as you can see, they're quite different, and even by not looking into them and treating them, you can tell that they were created kind of in different rooms and meant for different purposes, for different auditories, just by the general way that they look. Okay, so what are the usages for software architecture diagrams? I want to highlight two particular usages. From my opinion, the primary usage, the way that people use software architecture diagrams is for designing purposes. And what I mean by design is basically when you're trying to brainstorm the way that your new service will work with existing systems, the way you're trying to when you're trying to discuss with your teams, you would also prepare architecture diagrams to visualize and help people better understand the new feature or the new system that they are working on. You would usually put them in your basic internal documentation. Yeah, and speaking about the documentation, the next I would usually I think those two use cases, like design and documentation, they are quite different. So the reason being, when you are creating software architecture diagrams for design, they are typically short-lived. They're typically not maintained. Those kind of diagrams are often only used during the discussion and the initial development of the feature or product, and later on they're just kind of forgotten. And for the documentation, you would typically want to have the diagrams that are maintained and properly structured, and they usually have a better value proposition long time. Okay, so what tools you would typically use to create software architecture diagrams for design reviews, design documentation, etc. So here, really anything goes, anything that allows you to create and put the vision that you have in your head on paper to share it with your other team members. So you could use Drawio, Lucidchart, Miro, Excalibur, any tool that works for you. And for documentation, I think those tools are not a great fit. And let's discuss why. So what are the problems with documentation diagrams. So the first one I would say is usability, and usability can mean a lot of different things, but here I mean specific like ease of use of the diagrams. So for example, if you have a process in your team when you're creating the diagrams and linking them to the initial feature documentation, and you would have like 1,000 pages in Confluence, or it would be stored somewhere in Google Drive, people just won't be able to find it. Basically, that's the whole point. If it's hard to find your diagram, people won't be able to find it. People won't be able to use it. People will come to you with this question about the features that you build. They won't be able to use the documentation as they should. The next problem is abstractions. So what I mean by abstractions is that the diagram itself, it can be built with different levels of abstractions. So for example, if we're trying to diagram a Twitter, we could build a diagram that has like a user, a web application, and then a server, and say that the user uses a web application, and web application communicates with the server to send tweets at, and whatever. That's like the highest level of abstraction possible. But if you want to dive into the details and make a bit more detailed diagram, you would have like a diagram that goes into intricacies of explaining the queues, the caches, all the different parts of the backend, the services, etc. And it would be like a totally different diagram. And just imagine that for one feature, someone chose a higher level of abstractions, and for the other feature, another developer writing a diagram chose a more detailed level of abstraction. When there's a new person or a product person trying to understand a bit more how the system works itself, and they have to navigate multiple diagrams, this mismatch of abstraction levels would really make the job of understanding the system harder for them. And the last problem that I want to highlight is maintainability. So if we are talking about architectural diagrams for documentation purposes, those are the diagrams that would be used long term. They should be maintained, they should be updated, because if they're not updated as the system changes, they won't be very useful. I think a lot of you have probably seen the diagrams for your projects that are like 2 years old or 3 years old, and everything has changed from the time, so there is no use in them. You have to maintain them. And maintaining diagrams that are drawn with tools like Draw.io or diagrams or whatever, it's complicated for multiple reasons. First of all, being is if you have to add something new to your system and it's kind of related to multiple features, you have to go and to update multiple diagrams manually. Another example could be so there are kind of a lot of problems because it's first of all, you'll have to assign someone, give them enough time to do this task. It's tedious to look over all of the diagrams, update them, and it's kind of harder to do when we work with image formats. So let's briefly discuss what are the possible solutions to the problems that we highlighted. So usability has a pretty obvious solution. If you have a lot of diagrams already and you think you're not using them enough, this may be a sign that they're hard to navigate. So to help you that, you can start organizing them. You can either put them in one location on your Google Drive, or hyperlink them on your Confluence page. The goal here is just to organize everything. So for the abstractions, what we can do is that we can define some sort of notation and rules, and software architecture diagrams already have a lot of different kinds of notations. So there is notation how you would describe them elements. For example, like databases typically are drawn as cylinders, and services are drawn as rectangles, and caches are drawn as pipes or whatever. But those notations are not kind of mandatory. Whenever people start to write the diagrams, they usually look pretty different. If you introduce some rules and notations, you can make your diagrams look similar, and it helps the end user of the diagram to navigate it. And for maintainability. So maintainability is hard. There's really no easy solution. If you want to have your diagrams maintained, you have to maintain them. And there is common thought that if you want your documentation to be maintained good, you should treat it as your code. So here goes all the same rules for code maintainability. We can apply them also to diagrams. And to foreshadow what we are going to talk about next, there are tools that can help you solve all the problems and make it a bit more easier for you. Let's start the next section, and let's talk about a bit more about the abstractions. So for the software architecture diagrams, the ones that are mostly meant for the documentation purposes, there is a really interesting model that I want you to become familiar with. It's called C4 model. And what this model outlines, it basically outlines the abstraction levels that are possible in your diagrams. And by introducing these abstraction levels, you're saving yourself and your team a lot of time coming up with your own. So the C4 model proposes 4 abstraction levels. The first one is context diagrams. And context diagrams, they're meant to be the most abstract diagrams possible. And we will see the example of them shortly. But basically, they're meant to describe in the most easy ways, like the example that I just gave you with Twitter. It would be kind of context diagram. So we have all of our actors, we have all of our software systems, and the basic kinds of relationship between them. Those sorts of diagrams would be the most useful to wider auditory of people that don't want to know the intricacies of how the communication happens or which components that we have in our system. The next level that dives a bit deeper is a container diagram. And container diagram is basically a diagram of containers. Containers here being something that can be deployed and that can be and is deployed as separately. Think of a service. So you would think basically like your services are containers. Container diagrams dive one level deeper, and they give a better overlook of the system, explaining more details and intricacies. The next C in for Cs is component diagrams. So the component diagrams would typically describe components. Component can be like a library or a piece of your code if you have monolithic architecture or a module. Yeah, and the very last one, C, is code, which I think is pretty self-explanatory. Sometimes you want to document the diagram, and sometimes you don't. So what those abstractions are meant to achieve? The first one is standardization and clarity. So by using the same abstractions for all of your diagrams, you are greatly improving clarity for the end user. I think it's also quite self-explanatory. It's much easier to look at diagrams that feel as they were written by one person. Same goes for code. The next is multiple abstraction levels. So what this means, it's referring to the abstraction levels we just discussed, the 4 Cs. And it means that it allows different people with different needs to work with our diagrams and to still find them quite useful. We don't really want to overwhelm with product people if they want to know something about our system with detail that they don't need. So, for example, they probably don't need to look at the code level diagram or component level diagram, but they might be still interested in how, in the system context, like what third-party integrations do we have. Okay, the next point is flexibility and scalability. So the C4 model defines a really broad but also kind of standardized strict rules, but it can be applied to any system. You can describe everything with it. You can describe the Twitter in the many details. You can describe your simple application. It supports everything. And the last one is incremental approach. So incremental approach is referring to the way that they advise you to start building your diagrams. They advise you to start from the top, building the most abstract one, and then drilling down as much as you need. Because not all teams really need code level documentation or code level diagramming or component level diagramming. It really depends, and incremental approach allows you to get the value quickly out of your diagrams and to build them incrementally, basically. Okay, so let's quickly get familiar with, again, with the problems that we just discussed and the solutions. So implementing the C4 model would kind of close the abstraction point of the problem that we had. And to close the maintainability and usability, we can start using and introduce our tools. So there are kind of a lot of tools that support C4 model and provide you a way to write your diagrams as a code. One of them being Structurizr, another would be Architectural and Illograph. So why this presentation has Structurizr in the title and not Illograph? It's because I think Structurizr is a bit better than the other tools, and we will discuss soon why. And I also want to know you that C4 model was developed by the same guy that's working on the Structurizr, by Simon. Okay, so let's get a bit more familiar with Structurizr. Structurizr really is an ecosystem that allows you to build diagrams with code, and the code being Structurizr DSL. So Structurizr DSL is a specific language that was designed to write diagrams. But yeah, if we write our diagrams with code, we need a way to visualize them, to render them into pictures. And to help you do that, there are other tools. One of them being Structurizr CLI. So Structurizr CLI has the capabilities to export or convert the Structurizr DSL diagram to other languages, to Formate, to Illograph, giving you some compatibility and ability to switch to a different solution if you want to. There is also a program called Structurizr Lite, and it's available as a Docker container, and it allows you to render the diagram in your browser to view it, basically. So you can think about it as a viewer. Another tool is Structurizr on premises, and it's kind of like a heavier version of Structurizr Lite. It allows you to have multiple big diagrams. It allows you to view them. It allows you to edit them. It has some additional functionality. It's typically hosted in one place and supports access for many users, where Structurizr Lite is something you would use locally when trying to validate or check the diagram by yourself. So we would use Structurizr Lite when we are developing and when we are writing the diagrams, and we would use Structurizr on premises when it's already written and we want to show it to other people. And there is also Structurizr Cloud Service. It's a managed version of Structurizr on premises. It offers all the same features that on-premises version offers, but here it's managed for you, and it has free tier and also paid tier. Okay, so now that you are a bit in the loop about Structurizr, let's take a look at the diagrams themselves. So right here in front of your eyes, you see the very minimal Structurizr diagram. And right now we are looking at the system context diagram. So the first of 4 C's. So here we can see that we have some front-end system, we have back-end system, and the cool thing about Structurizr is that the diagrams are interactable. So by clicking here, I can jump to the lower level of abstractions. So we have just used like system context, where we have all of our systems and all of our actors that are connected for that systems. And here we are looking into backend system. So backend system consists of public API and private API containers. And we also have like some sort of relationship between them, and we can see that another software system interacts with our public API. That's the second C, container level abstraction, or services. You can think of as the services of containers. And the next level is basically component diagrams. So this would typically be like a module in your service that's responsible for managing users. We have user service right here. It's a part of private API container, and we can see that public API directly talks to our user service. Okay, let's take a quick look at the code that renders the diagram. So right here, you can see we have some sort of structure. We have workspace. Workspace basically like is the main key that we have. And we have 2 different keys inside it, model and views. So views are basically the diagrams that we see, and models, they define the services we have. So we just have viewed system context diagram, this one. So this diagram itself, it's fully explained and fully rendered here. So we use like one view refers to one diagram. So the system context diagram is described here. The container diagram that we also viewed described here, and the component level diagram is described here. What we have going on in the model? In the model, we have to basically describe our services and to list the interactions between them. So we here have our backend software system, and we can store it to a variable if we want to reuse it later, or we can not store it to a variable if we are planning to reuse it later. Inside our software system, we define our containers the same way, just using different keywords. And inside our containers, we are defining our components. Again, just using different keywords. All the syntax is pretty much the same. Same goes for the front end. And here we can see a relationship. So backend, like private API, user service, all of those elements are represented in this case by rectangles. And the relationships are typically represented as an arrows. So right here we have an arrow. And here we have one as well. Yeah. So basically what it says that public API uses user service. And here it says that front end uses public API. And it's actually a shortened syntaxes. You can also like write it fully and you can place it everywhere. Really, it doesn't matter that much. Yeah, another cool thing about Structurizr is that it allows you to, yeah, so basically what we just witnessed is that we had to define our system once using Structurizr DSL, and then we had reused those definitions 3 times to build 3 different diagrams. Yeah, and that's the whole point of Structurizr. Basically, you define all of your relationships and components once, and you can build pretty much any kind of diagram. So we can build not only system context or container diagrams or component diagrams. We can also build custom diagrams. There would be like custom views here. We can include or exclude some containers, some services, some components from the diagrams. By default, there's an auto layout. But if we remove it and if we refresh the page, we also get a button, or basically we also get the capability of moving things around. You can rearrange this stuff. You can also play with different auto layout options to draw the diagram differently. You can change the canvas sizes, etc. It's really gives you a lot of capabilities to update the diagram and to make custom diagrams. Okay, and now when we are pretty much familiar with the basics, let's take a look at a bit more complex diagram. So right here we have a bit complex diagram, a bit more complex diagram. It describes some sort of a service, some sort of a product that our company that has different products, different features. Let me zoom out a bit. Okay, yeah, and again, we are viewing now we are viewing system landscape diagram. So a system landscape is kind of like a composition of all of system context diagrams. It's everything that you have on the highest level of abstraction. So here we have all of our actors, like internal user, API user. We can see that internal user uses admin web app. That's admin portal. admin web app is supported by admin backends, which in turn uses the regular backends, and regular backend is using third-party mail sender that's described as software system here. We also have like our iOS application, we have our web application that our user uses, and we have our API user that uses directly the backend. So let's dive a bit deeper. Let's see what we have in our backend. Okay, yeah, so this is system context view, the first of 4 C's. Here we can basically see like backend as a software system, what is it connected to, how it's being used. So we can see that we have an actor here, API user that uses the backend directly. We also have like an admin backend that uses the backend. We have web application, iOS application, same integration that we just saw, and we can go and take a look quickly at the admin backend. Yeah, so let's take a look at the admin backend. Yeah, admin backend itself, it's not detailed here, so we are just viewing the system context diagram of it. Let's take a look at what changes, what do we have in our code. So it looks quite similar to the first example that you saw. It has the same like views models. Right here we have 3 views: system landscape, system context for backend, and system context for admin backend. Those are the diagrams that we just saw, like system landscape, system context, and another system context for backend. What had changed is that now we have like cute stick figures to represent our users, a robot figure to represent our API user, and we also have web page and smartphone to represent our apps. And we also changed the color of mail sender to be different from other services. It's third-party integration. So how had we achieved it? These changes, and really Structurizr has a lot of capabilities to make the diagrams more visually appealing. You can change the format of arrows, color of arrows, the color of your services, backgrounds, anything. You can add icons, you can change shapes, and all of the stuff is contained in the style scheme. So right here we're just defining some colors in the same way we would define constants in most of the languages in a similar way. Here we define properties for the standard element, basically for everything, like base settings. So we have rounded boxes, we have gray background, black color, and black strokes. So we would have like black strokes, black color, gray background, kind of splashed rectangles. And then we are just defining different properties for specific tags. So for element-based tag user, we would draw it as a person, and same goes for all of the other elements. And to apply, to add those diagrams, you would put them in your, to add those themes, you would put them in your workspace view under the views key. But if you do so, like directly, if we describe them here, it looks kind of a bit overwhelming because we have a lot of new codes we have to scroll. And my recommendation is when you start building, start working on the Structurizr diagrams, start early with separating the code into multiple files. So that's just what we did here. We used the keyword include to include file themes DLS, and we just saw our file theme DLS. It got included into our workspace under the view key, and that's why we have all the cool details that we have. So the same thing I used for describing our elements, our components, and software systems. I had moved them into their separate file. And we will take a look at them shortly, but also you could notice that we have a new keyword called groups here. So what groups basically do is that they allow you to group different components together. You can choose and pick and use any group you want. It will affect how your diagrams are drawn. So all of our group members are drawn together, and we have like a small dotted line around all of them, and the name of the group here. It's totally optional. You can not use it, but I also recommend to group your elements like software system services. It helps with rendering of diagrams, so all of the stuff that's related is put closely together. So let's take a look at the system's backend. We have kind of the same logic here as we saw in our previous example. In the first example, we have software system, container, at relationship. Same thing happens here. We have our backend software system, we have our admin backend software system. It has some sort of description, it has relationship. Front end is pretty much the same thing. Here we have text, and if you remember, I was just talking about text. We were defining them in our themes. So, for example, we have tag mobile with shape mobile device portrait. And by applying this tag to software system, we are drawing it as a mobile instead of it just being a plain rectangle. Integration, same thing. Yeah. So now that we are a bit more familiar, let's move to a bit more complex example. Here you see all of the same system that we had just discussed, but we added a bit more information to it. Now we have descriptions over our relationships, giving you information like how it would, what is the interaction here between the admin backend and the regular backend. We are making API requests from admin backend to regular backend using REST over HTTPS. And let's take a look at what containers does the backend system consist of. So right here we have our container view. We have our public API, private API, database, drawn as a database. We have our file storage. We have our backend microservices, content service, and fanout service. We also have third-party integrations. We have different software system admin backends, all displayed here in our container view. And we can also take a look at the admin backends. Yeah, by the way, you can, to view different diagrams, you can either hop on from one to another by clicking on the elements, or you can use the menu to the left, when you can pick the diagram and view it. Yeah. So the admin backend right here consists of admin service, and admin service is a container. And inside that container, inside that service, we have a couple of components. We have a user management component, we have a content management component, and we also have an audit logger. So audit logger here is being used by both of those components to audit actions that admins do, and it stores the logs in admin database. And content manager and user manager are calling to the regular backend to make changes that they need to make. Okay. Another thing that I wanted to mention is that you can add actual existing documentation pages that you have about your system to the diagrams and hyperlink documentation. So for example, right here, I have added a URL to the Postgres. So whenever I click on Postgres, whenever I click on this administration database, it takes me to that URL. You can put a pgadmin URL right here to allow people to navigate to the database, maybe look at it more closely. You can also put links to your existing documentation about services, to conference pages, so people can navigate and get a better understanding on how components work. Okay, and so let's take a look at what had changed in our diagram. So right here, it stays pretty much the same. We have a bit more views defined. We have system landscape as we did previously. We have also system context that we saw previously. Now we also added container diagrams and component diagram. Remember that each view here, it represents a single diagram. Here also not a lot of changes. I just had separated the backends from one file to two separate files. And as you will be building the diagrams, it's pretty much the process that we will also go through. We will start by building a simple concept system landscape diagram describing high level how all of your systems interact. And after that, as you drill down and build a more detailed diagrams, describe more components, describe more relationships, you would separate different software systems first into separate files, then you will separate software systems into components and put them in those in different files. Yeah. So let's take a quick look at the admin backend and the backend because we had some changes here. So for admin backend, you saw that I had added URL to our admin database, and it can be accomplished by just adding a URL tag, URL keyword inside the container, and you can place any URL here. The database tag basically responsible for drawing database as a cylinder and not rectangle. We also specify technology here. It's totally optional. All of these fields are optional. Admin service, it also has some description, technology, some documentation URL. And inside our admin service container, we have multiple components like admin database, user manager, content manager, and stuff. Yeah, and that's pretty much the same for the regular backend. We're describing all the containers here, all of the components. We also have group for our backend services. It all can be nested. Yeah, another thing that I want to mention is that you can put your URLs not only into the elements like container or software system, you can also add it to your relationships. So if I put the URL here to the mail sender, and if I reload the page, I would be able to, let's see where we have it. Okay, it's backend service, fan-out service. So if we go to the backend software system and fan-out service, this relationship becomes clickable. It will take us to some page. And what you can do is that you can put your open API documentation or Swagger documentation in those errors to allow people to quickly view what protocols, what interfaces you're exposing with your private API or public API, etc. Okay, yeah, let's move on to other features of Structurizr. So here we have all of the same elements, all of the same diagrams. I haven't changed anything except for perspective. I had added a perspective, and the best way to explain to you what a perspective is to show how it works. So by selecting a content perspective here, I just changed the way that the diagram was rendered. You can see here that we have our mail sender grayed out. And we can also see that we have like some relationship grayed out. Why? So the perspective is a tool that you can use to explain what roles your elements and relationship play in the context of specific scene. For example, like in the context of monitoring or log gathering, or in terms of security, like what role does this component play in terms of security of the system overall. And it allows you to display additional information. Like here, we can hover on to our user and see that for perspective content, it creates and consumes content. So user plays this role, and internal user, we can see that in relationship to content, in perspective of content, it moderates content, and API user, it only consumes content. So it's probably like some API for scraping user data or something. And we also have like our iOS applications that displays content to user, and we have our web applications that does the same thing with the iOS application. We have our admin web applications that supports administrative capabilities of our admin users. We also have some perspective information here that user, in terms of iOS application, uploads and downloads content, and iOS application sends that content to backend. And we can drill deeper, and we have, sorry, pretty much the same thing going on here. We are just describing additional information in a given context to all the services that participate in that context. Fan-out service that's used to send emails, it's grayed out, and all of the relationships to it are grayed out because it has no relationship to the content. It doesn't really interact with it. So it's not relevant, and we are graying it out. So let me show you really quick how those perspectives were added. Again, no changes in workspace DSL. Let's take a look at backends, for example. Yeah, so here we have added perspectives by simply adding a keyword perspectives here. We define like the name of perspective, and then we can optionally add text that would describe like what role this component or relationship plays in this context. We can have multiple perspectives here. To add multiple, you would just go to the new line and say like monitoring, handles monitoring and alerting, whatever. You would use the same syntax to add perspectives to the relationships. So right here you can see that we have a relationship from the content service to Minio. And what it does, generally it reads and writes to Minio using FTP. But in the context perspective, to be more precise, it stores and reads content over FTP. Okay, now that that's settled, I want to show you another thing that's possible with Structurizr. So by now we have already discussed system landscape view, like this view, overview of all of the systems. We also have discussed system context view, the first of the 4 C's. We discussed component view. We discussed container view. Another type of diagrams that Structurizr supports is deployment diagrams. And deployment diagrams are meant to represent your deployment topologies. So you'll typically have like multiple deployment environments. You can have test, you can have staging, you can have production. You can have like separate deployment for your B2B needs. You can also like use Structurizr to describe in one place all of those different topologies. So right here, we have our deployment diagram for our backend system. And this deployment diagram, it shows us how our backend system would be deployed in test environment. So if we zoom in a bit, we can see that we have our public API, we have our private API, all of the relationships of the services still visible, but now we have some blue lines over here. Well, what do they mean? Okay, so we can see that all of these services, they are located in the namespace backend test. So it's like Kubernetes cluster, namespace backend test, and we have all of our services here. We have our fanout service. It's deployed as a service test fanout service, and it can be scaled from 1 to 10 pods. Or you can put here like 5 to specify that it has 5 instances. Pretty much same goes for the database, for the content service, for the private API, Minio. It's all really similar. What you can do with deployment diagrams that I'm not showing here is that you can have, as I said previously, multiple topologies. You can describe how your production works, how your production is being deployed, how your B2B production is being deployed, and you don't need to create a separate diagram to start from the blank page every time. We are reusing all of the same services that were defined once. We are just adding a bit info about a bit more additional information about how they deploy it. Let's take a quick look at the deployment diagram. Yeah, so here's no changes from the previous examples. We have identical stuff, identical services, identical components. But we also added deployment file, and we are including it in our workspace right here. So what do we have in our deployment file? We have test deployment here. And so to describe deployments, there are 2 tools. There are 2 keywords: deployment environment and deployment node. Deployment environment, it's like you just have to specify what environment are you describing, being test, prod, staging, whatever. And another thing is deployment node. The deployment node is basically like a box and you can call it whatever, and you can nest it however many times you want. So right here we have a deployment node backend test, and its namespace is a Kubernetes namespace. And as you can see here, we have a tag Kubernetes namespace. If you remember, tags are described in the theme file to specify how we draw different themes. So let's take a quick look at the theme file. We don't have really any changes here in the style that we had defined previously. But what had added is that we introduced new keyword, theme. So the theme keyword allows you to use a theme that other people had already built. You can include it into your themes file. You can include it into your diagrams. And here we have a theme from Google Cloud. And here we have a theme for Kubernetes. So those themes come with their tags, just like the same tags that we created ourselves, and they have like predefined icons, predefined colors. So that's the reason why we have here like this icon and this color. If you want, you can create the theme all by yourself. You can describe it by yourself, add your icons, add your colors, add your shapes, or you can import using the theme tag existing theme. Or you can mix and match like we do here. We have our definitions for themes, and we also import the existing ones. It also works. Yeah, so back to describing deployment. We have the deployment node, backend test, which is on namespace. We have deployment node test public API, and it's a service. Inside of it, we have deployment node pod, and we have to specify here that this pod is being used to deploy our public API container. Same goes for the other containers, like private API, same descriptions. We can omit specifying tags here. Depends on if you want to have different colors in your diagram. We specify deployment node, we specify container instance, and like these two deployment nodes, they are drawn, as we can see, around your service. Yeah, and that's basically it. That goes for the deployment. You may not specifically need to create deployment diagrams if you already like use some tool for visualization of your Kubernetes clusters. If you have, I don't know, Argo CDs that have some visualization, you may need those diagrams. But if you do these things, Structurizr allows you to do it quite easily. Okay, the next thing that I want to show you is documentation. So what we had discussed previously are all of the diagrams that we can build, but what we can also do with Structurizr is that we can host our documentation using Structurizr Lite or Structurizr on premises. Structurizr supports Markdown and stdoc formats. So you can put your text, your different pages here, and we will see shortly how to do it. But what it also allows you to do, it allows you to hyperlink your diagrams to be inside your documentation, to be viewable, and to be interactable. So we are basically like viewing markdown file here, but we have our diagram and we can interact with it and we can click around it. We can zoom in, zoom out, switch perspectives. I think you can figure out some pretty cool use cases with it. Let's take a quick look on how to add documentation. Yep. Okay. So in our workspace, we just have to use the keyword docs and specify the path to the folder with either Markdown or ASCII-Doc formatted files. It does matter where we place this kind of an include statement. If we place it here, it means that this documentation is related to the whole workspace. If we place it inside our backend group, it would mean that our documentation relates to the backend group. If we place it inside our admin backend, I don't know, for example, like admin database, it would mean that this documentation only relates to our admin database. And to add documentation for admin service, you would place different folder here, I don't know. Let's figure out something. Docs admin, and let's try to add it. Let's save and let's refresh. Okay, yeah, that's there's an error, but I don't want to debug it now. Okay, but okay, forget about it. Yeah, what you can really do is that you can hyperlink your documentation to container, to components, to different software systems, and host it also with Structurizr. Let's discuss how can we create the cool view with interactable diagram. So to do it, you need some HTML magic. You need this code. And how had I obtained this piece of code? I had used Structurizr on premise. So yeah, welcome. It's Structurizr on premises. You typically have it deployed on servers and available to all of your colleagues, all of your employees. And you would typically push your diagrams to Structurizr, and people would be able to go to it and to view, to interact with the diagrams. It's yeah, let me log in. It's quite similar to Structurizr Lite. You just saw that it has different workspaces, meaning that it can have can host like workspaces, like a folder for diagrams. So you can have like multiple folders for your diagrams. And in the view itself, you have more buttons, so it has more capabilities. For example, you have this button embed, and the button embed gives you the code to embed basically this specific diagram to your documentation, and you can embed it to documentation that's hosted by Structurizr, or you can embed it into a different documentation. Like for example, here we have documentation built with swings, and let's go to the architecture. And as we can see, we can also hyperlink like diagrams to the other documentation that we might already have. And again, it will be completely interactable. just as when we were hosting the documentation with Structurizr on premises. Okay, so continuing the theme, the topic about Structurizr on premises, how would you typically use it? So Structurizr Lite and Structurizr CLI might be useful for the local development, and the diagrams, the code that you wrote, you would typically put them in your VTS, be it GitLab or GitHub or whatever. And in your VTS, you would typically want to have automated CI/CD that would take that diagram and push it to your Structurizr on premises. Structurizr on premises being like the final location of your diagrams. It's one location where all of your diagrams live. And it's really easy to do with the API. You just have to make one simple request. Yeah, and that's it. I also want to add one thing about building a review process. So typically, if you have multiple people working on the documentation at the same time, you want a really easy way to review the diagrams, and how one way that it can be achieved is using the diagram review tool that Structurizr on premises offers. But this tool is quite new and it's kind of in beta, so I cannot recommend using it. Another way of doing reviews of the Structurizr diagrams would be to do it basically in your VTS. So you can review the code, all of the diagrams, like, or all of the DSL. You can also set up an automation that whenever new merge request is created or push request is created, you would take the changes, take like the branch and take the diagrams in the branch and push them to a different temporary Structurizr workspace, and add the link to that workspace to your PR. This way, it would allow people to quickly jump to the diagrams and take a quick look if they are looking fine or not, without cloning their changes and running them locally with Structurizr Lite. Yeah, and, I think that's all the things that I wanted to share in the demo section. So let's get back to the presentation for a couple of more slides. Okay, so the important question that we haven't discussed yet is that does your team actually need this? Does your team need this process of building diagrams with Structurizr? Do you need those diagrams? It's an important question to ask because as any documentation, as anything that you do at work, it takes resources, and if there are no end user for this product, which being the diagrams, it might not be worth doing it at all. So how I would approach this issue is that those diagrams, those kind of diagrams that are certainly really beneficial to people who are just joining your team. People who are onboarding would be really thankful you for the documentation. So if you have a lot of new people coming to the team, you might want to invest some time into building those diagrams. Another point is that if you have a lot of people coming from different departments, different teams with questions about how you build that, how you build this thing, how that thing works. We want to integrate with you, and we want to know, to have a bit more details to understand better how your system works. If you have documentation, if you have diagrams, you can just direct them to the documentation, to the diagrams. If you don't, you would have to set up a call and spend some time talking to them about your system. So if you have a lot of calls, a lot of such calls when you explain your system, it's usually worse investing the time to building the diagrams. When you certainly need to invest your time into build diagrams is if your company has like a mandatory, policy of like training every 6 months or so, or every year, where you are forced to go and to learn something new about the system. I think it may also be beneficial to use that time instead of viewing lectures to actually try to build and to build the diagrams, in the process of building the diagrams to understand how the system works and to create the documentation for the later use. Okay, that's everything that I had for you today. I hope I haven't left out a lot of material. If anyone has any questions, it's time to ask them